Hello, so today we'll be solving this LeetCode at 57 minimum cost to hire K workers. So basically in this question, they have given us two arrays. So one array contains the quality of the worker and another contains the wage of the ith worker. So if the quality of the ith worker is 10, then its wage will be 70. Also they have given us a key value. So what they want us to do here is they want us to basically hire two people from this pool of workers. So from these three workers here, they want us to hire two workers in such a way that first of all, whatever wage, whatever the total wage we are going to pay, it should be the minimum possible. So that's a given that we have to give the least amount of money. And to solve this, they have given us two conditions. So one of the condition is that any worker that we have chosen, it must be given at least the minimum wage. So for example, if you choose one of the workers, that this is not actually the accurate wage, it's just like the minimum wage the worker is willing to work at, and he can also take more than that, but at least this much he needs to work. So that's one of the condition. And the next condition is that each worker's pay must be directly proportional to their quality. So basically, let's say we take this worker that has 20 quality and 50 is its wage. So for one quality, the wage will be 2.5. So if we decided to hire this worker, then any other worker that we are going to choose, we are not going to look at their wages. We'll just look at their quality and then pay them according to this. We just have to take care that whatever this is, this must be greater than or equal to their minimum wage. So that's all we have to do. So what is the intuition, or how are we going to approach this problem? So initially I thought this problem like similar to the knapsack problem, where we have given as some weight and there are some items with specific weights and value, and we have to maximize the value of the knapsack with the least weight possible. So it felt something like this. Okay, so basically I'll explain with an example how we are going to solve this. Okay, so I have taken the same example they are given. So basically these are the two arrays, quality array and wage array. So first step would be to find what the correct rate is. So this wage currently doesn't mean anything because it is related to the quality. So what we'll do is we'll find out how much wage the worker takes per one quality. So we can just do that by dividing the wage by the quality. So for this worker the rate is 7 per one quality. For this worker is 2.5 and for this worker is 6. So what this basically means is for one quality of work this worker will take 6 wage, or let's say 6 rupees. For this it will take 6.5, sorry, and for this it will take 7. And why we are calculating the rate here is because as they have given in the second condition that whatever we choose the rate of one of the workers, we have to pay all the workers according to that. So if you choose like 7 here, so these two rates doesn't matter, we have to pay the other worker also with this rate. So that's why I have taken a rate here. So the next thing would be to do is to we are going to sort this. So let's take the wage out of equation here, because we are using this rate as an intermediate solution for this, and we can calculate the wage anytime using this rate and the quality. I'm going to remove this wage basically, and what we are going to do next is we are going to sort this quality array with respect to the wage in the ascending order. So why we are going to sort this in the ascending order? So we are simply using a greedy approach of selecting the workers with the least amount of wage. So if we sort this, what will happen is 2.5 will, okay, let me create another array. So basically we'll sort this according to the rates. So 2.5 is this work, 2.5 is the least wage, so we'll add it the first because we are going to sort in the ascending order. So 20 will be the first quality. Rate will be also sorted according to that. So this will be basically for 20 it is 2.5, for 5 it is 6, and for 10 it is 7. So now that these both of these are sorted, what should be our next steps? So basically currently k is given as 2. So what we can do is we can start by adding these first two, these and these, into our group, and after adding them we will calculate what is the total wage that we are giving them, and then we will okay. So when we calculate the wage for total wage for both of these, what we'll have to do is we'll have to move to the next one, like this one. So what the problem here will be, to add this one, k is equal to 2, so we cannot add more than 2 elements. We will have to eliminate one of these. So which one we should eliminate? So basically we will just eliminate the person who has the highest quality. Why we are eliminating the person with the highest quality? Because the wage basically doesn't matter at this point. The wage will be decided by what the next element will be added, because we have sorted the array according to rate, and this will have the highest rate, so all of these must be paid with this same rate. That's why this wouldn't matter. What will matter is what is the quality of that person. So here also we will use like greedy method to basically remove the person with the highest quality, so that least amount of wage can be given to them. So we'll just use a maxif to choose which element to be deleted next. So maxif will always have the element that needs to be deleted with the highest quality, so that will make things easy for us. So let's use a maxif here. So let's say maxif. So we'll add this here. It will be 20. Then we'll add 5 here. Now that the size of our maxis is basically 2, so to add the next element we'll have to remove one of this element. So max sweep will always remove the largest element possible. So it will remove 20 from here and it will add 10. And there might be like currently this is a small example, but there will be a lot of numbers after this. So basically the max if will compare all of them and always remove the person with the highest quality, and in the end we'll take the whatever the minimum wage of it is. How will we calculate the total wage? We'll just add this quality. So this is basically 5 plus 10. So we'll just multiply 5 plus 10 15 by 7, which will basically be, so the answer will be basically 105. So let's actually code this. Okay, so let's code the approach. Basically what I'm going to do is I'm going to, like always, use like some more readable and maintainable code. So I will not be using an array to store this. So basically I will just create one class called worker. He will have a quality associated with him, a wage associated with him, and rate of work. Rate of work will be basically a double. Let's write a constructor also. We'll not take the rate as parameter here, we'll just calculate it on the fly. So this will be wage divided by quality, not quality divided by wage. Okay, so now that we have this class worker, first we will create an array of these workers. So we have basically populate the array of workers. Now what we'll do is we will just sort that array. So basically the array dot sort cannot sort this array by itself. We have to give it a comparator. So what we'll do is we will use so you must know like the arrow functions in the JavaScript. So like that arrow function, we have this lambda function in the Java, where we can just write a anonymous function. So I'll write this for workers. So this is the A will be the first object and the B will be second worker. So these both are workers, so we have to compare them. When we can return a positive number, a negative number, or a zero. I think I discussed this in the last question. So we'll just compare them. Now what we have to do is we have to compare them according to rate. We have to sort them in the ascending order. Okay, so this will basically sort the array of workers. And now that this is sorted, we can actually start working on the solution. So I will just create a priority queue here with worker. Now same thing here also. We can actually provide a comparator to the priority queue directly. So using that comparator, the priority queue will sort its objects. So what we can do is, just like last time, we can again create one comparator called compare worker, which will implement the comparator. And we have to just implement one method called compare. It will get sent two variables, the worker A and the worker B. We have to basically just return this same thing here. Now pay attention here. Before we compare the workers by their rate, but now in the priority queue, as I discussed earlier, we will be comparing them with their quality, because we want the person with the highest quality to be at the first in the queue, so they will be removed first. I think we'll just reverse this. Instead of ascending order, we will just do a descending order. So if the quality is less, then this will return 1. So this will basically sort the our priority queue in the descending order. And we'll just add this comparator here. To add comparator, we can just create one object here and pass it to the priority queue. When our priority queue is also ready, we just have to implement the logic. First we will take one answer, which will basically be the maximum possible. Then we'll just go to the loop. So we are going to the workers array one by one, and we'll add those workers to our priority queue. Okay, I forgot to name this variable. So we'll first, so when it comes to queue, we use method like offer to add an element, and to remove an element we use queue.poll. So these are related to queue. For stack we use push and pop, so same in the queue we use offer and poll. So what we are going to offer here is basically we'll just add one worker here, whatever the workers of I is. Also while adding this, we have to keep track of what is the current rate and how much quality we have collected yet. So we'll also have one int variable which will be basically initially 0. Then we'll just add the whatever the quality of the current is into this. Now that this is added, what we'll do is we'll check if our queue has enough elements. So basically if our queue has k elements or not. So I will add one condition here. If queue dot size is k. So when our queue has k elements, what it basically means that we have created one group. So we have one group here. So we'll just update the answer accordingly. So answer will basically just math.min of the previous answer, the new answer. To create a new answer, we'll just multiply the total quality by rate. Okay, so instead of using like array of I everywhere, so this just makes it more readable. So whatever the current rate is, it will be multiplied by total quality and we will have an answer. And what we will do if the size of the queue becomes greater. So when our queue size is greater than k, what we have to do is we have to remove one element, and we can just do queue.poll here, because the heavy lifting, the comparator is the one doing heavy lifting here, which is comparing the quality and then deciding which element to remove. So we'll just do queue.poll. Queue.poll will return one worker variable, so we'll just remove it from the total quality. Okay, and in the end we'll just return answer. So let's try running this. Making a lot of mistakes today. Okay, this works. Let's try submitting. Okay, so I think this is efficient, and also we have used whatever the oops concepts are, or like we have used the class, we have used this comparator interface, and also we have written logic, so at least the code is more readable. So yeah, thank you.